I'm Seema and welcome to part 30 of the chapter Hydrocarbons. We were doing the chemical properties of alkenes, and in the previous video I told you that based on ozonolysis of alkenes there are a few questions in your NCERT textbook exercise. In this video and in the next one I'm going to do these problems. I'm going to explain these problems or solve them for you. Because by solving these problems, ozonolysis and the process of ozonolysis and how to derive the products of ozonolysis will become clearer to you. So let us do in this video, I'm going to do question 13.4, which is your textbook exercise question. The question reads that write the IUPAC names of the products obtained by the ozonolysis of the following compounds. The first, it has 4 compounds and you have to carry out the ozonolysis of these 4 compounds and find out their products and write the IUPAC names of the products obtained. So the 4 compounds are pent-2-ene, 3,4-dimethylhept-3-ene, 2-ethylbute-1-ene and 1-phenyl-bute-1-ene. So let us now start solving the problems one by one. The first compound is pent-2-ene. So let us write down for pent-2-ene. Okay? Let us write down the structure of pent-2-ene. Pent means there are 5 carbon atoms. 2 means the ene is present on the second carbon atom. So the first would be CH3. On the second carbon, there's a double bond between the second and the third carbon. That is why the ene is on the second carbon. And there are 5 carbons in all. So this carbon makes 3 bonds. So how many hydrogens does it need? 1. And this carbon also makes 3 bonds, one with the carbon adjacent to it. Therefore, this also has a hydrogen here. And 1, 2, 3, 4 and 5. This is pent-2-ene. Now, you carry out its ozonolysis. To carry out the ozonolysis, you make it react with O3. And when you make it react with O3, I'm going to, since it is in 3 steps, I'll put the arrow here, but I'll be writing the product here. And then the next, the reaction, we'll carry on writing this way. So this is pent-2-ene. If we have to carry out the ozonolysis, how is the ozonide formed? We know that as an intermediate, this ozone molecule, it gets added on to that part where the double bond is there. It causes the lysis, that is the breaking of the double bond, and the ozone attaches itself to these 2 carbons which were attached by a double bond. So, as the intermediate, what is the ozonide that we'll get? So, in order to write down the ozonide, you'll write down the compound as such. Only in the place of the of the double bond, you will make the changes. So let us write this down. CH3, CH. Now I have avoided the double bond here because this is where between these 2 carbon atoms the ozone molecule is going to add up. And the ozone adds this way and the rest of the molecule remains as such. So this was CH, this remains CH2, CH3, right? And this is the ozonide. It was pent-2-ene. It is the pent-2 ozonide that you will get. Now, in the next step, you make it react with zinc and water. Alright? When you make it react with zinc and water, the ozonolysis, actually the breaking down takes place and you get 2 products. What will the 2 products be? The breaking is going to be here and here. This oxygen remains, it will form H2O2, but this part is going to, the bond that breaks here will form a double bond with this oxygen. Similarly, the bond that breaks here will form a double bond with this oxygen, and this bond is also breaking. So when this bond breaks and this bond breaks, oxygen gets 1 electron, carbon gets 1 electron. They share that pair of electrons and form a double bond. Similarly, when this bond breaks and this bond breaks, oxygen gets back its electron, carbon gets back its electron. They share that pair of electrons and form a bond. So, what is the product that you will get? You will get CH3, CH remains as such, and this carbon forms a double bond with oxygen. Plus, on the other side, when you're writing the product, it makes it easier to write it from the opposite side because in the end you want to add the double bond O. So you write CH3, CH2, CH double bond O, right? So now what are the IUPAC names of these products that you get? So now you'll get these two products, and let us name these, give the IUPAC names to these products. This is CH3CHO. And what is CHO? CHO is an aldehyde. And there are two carbons in it. So which aldehyde is this? It is ethanol. So you write the name, the IUPAC name of this compound is ethanol. And this 1, 2, 3, it has 3 carbons and it is also an aldehyde. So this is propanol. And you know, the carbon, since the al, that is aldehyde, is a terminal group, you will always treat the carbon which has the double bond O as the first carbon. So this is ethanol, this is propanol, assuming or understanding as a rule that the carbon having the double bond O is the first carbon. So there is no need of a locate. Let us come to the second example here now. In the second example, what is the compound? It is 3,4-dimethyl hept 3-ene. Okay, let us write down the structure of this molecule now. 3,4-dimethyl hept 3-ene. Hept means there are 7 carbon atoms. So let's make the carbon chain first. 1, 2, 3, 4, 5, 6 and 7. There are seven carbon atoms. On the third and the fourth carbon, there are 2 methyl groups. So CH3 and CH3. There are 2 methyl groups, and hept 3-ene, the double bond is also between the third carbon and the fourth carbon. So here you have the double bond. Now fill up the hydrogens to saturate every carbon every carbon should be forming 4 bonds. So this has only 1 bond, so there will be 3 hydrogens here, 2 bonds, there will be 2 hydrogens here, 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds, no hydrogens required, 2 bonds, 2 hydrogens, 2 bonds, 2 hydrogens, 1 bond, 3 hydrogens. So every carbon in this way is forming 4 bonds. So we wrote down the structure of the compound. Now this is undergoing ozonolysis. So add ozone to it. And in the next step of the reaction, as the intermediate, we are going to get the ozonide here. So how will you get the ozonide? I told you, all you have to do is remove the double bond and add the oxygen, the 3 oxygens to the compound as it is. So all you have to do is write down the same compound in the same fashion. So I'll write CH3, CH2. Now this CH3 and CH3 I've written perpendicular. If I just slant these a little on a side, it means the same thing, only it gives me a little space, or it makes the ozonide clearer. Then you have C here and the CH3. This CH3 also I've slanted it slightly. CH2, CH2, CH3. The compound remains as such. And the ozone adds itself here to form the ozonide. Right? In the next step, what is added to it, or what takes place? In the presence of zinc and water, what is going to happen? The ozonolysis is going to take place, the cleavage is going to take place here, and as I told you, as the bonds break, this bond breaks, this bond breaks, oxygen gets its electron, carbon gets its electron, this should form a double bond here, this should form a double bond here, the oxygen will be used up by water to form H2O2. So let us write the main products that we are going to get. So to write the main, the 2 products, you again will be following the same pattern. Only for this carbon, you will be putting a double bond O and then writing the IUPAC name. So this will be CH3, CH2, C. Now this has CH3. I can write the CH3 here now and the O here. Do you see? Now, as soon as carbon, which is bound to an oxygen by a double bond, has got methyl groups or alkyl groups on 2 sides, it is not an aldehyde, it's a ketone. So this is a ketone now. And which ketone would it be? It would be butane 2-one, right? So, and let us first write the other product. I told you, let us start writing from this side. So this will be CH3, CH2, CH2, and this carbon would again have a CH3 on one side and it forms a double bond O. the methyl groups attached, I put it in a straight chain because by doing that, it makes it easier for me to understand what compound it is. I could have written it slanting this way or straight up, but that would, when you're giving the IUPAC name of the compound, that would only mean that the chain has turned. But the longest chain is still this. So this is also a ketone. So let us write the names of both the ketones. This is butane 2-one, and this is 1, 2, 3, 4, 5 pentane. Pentane 2-one. The ones are on the second carbons in both of these compounds, right? So you get butane 2-one and pentane 2-one. Give me a moment to clear up the board and then we'll solve the next problem. Let us now solve the third part. The third part says, I'll not write it again because it's written, or let me do it, let's not be lazy. 2-ethyl but1ene is my compound. Let me write it down first. From the IUPAC name, I'm first going to write down the structure of the compound as I've done for the other two problems. Then we'll carry out the ozonolysis, then we'll get the products, and then we'll name the products by IUPAC rules. So 2-ethyl but1ene. It's butene, and to the second carbon, an ethyl group is attached. So if it's butene, let me first write down the 4 carbons, okay? It's but. But1ene means the first carbon has the double bond, but the second carbon has an ethyl group attached to it, that is C2H5. 2-ethyl but1ene. 2-ethyl but1ene is your compound. Let us now complete the hydrogens here. I just wanted to confirm that the compound is right. So this has 2 carbons, so this should have 2 hydrogens. This is already forming, this carbon is already forming 4 bonds, so it needs no hydrogen. This is forming 2 bonds, so it needs 2 hydrogens. This is forming 1 bond, so it needs 3 hydrogens. We carry out the ozonolysis of this molecule. When we do, what happens? The double bond breaks here and the ozone will add wherever there is a double bond between the carbon atoms. The double bond, you will clean it off, or when you're writing it, rewriting it, you'll skip the double bond and you'll add the ozone there. And that will give you the ozonide, the intermediate. And then from there, you will break the ozonide, the lysis will occur, and you'll get the product. So here you'll get CH2, and that remains as such C2H. Now again, you know, it would be better if I put the C2H5 with a slant here. Let's put a slant here and write C2H5. Just for the sake of similarity, let me write the C2H5 here. Okay, so that it appears similar. All I did is I slanted the bond a little, and the rest of the molecule remains as such, CH2, CH3. And between these 2 carbon atoms is the ozonide ozone going to attach itself. So oxygens here, 1 oxygen here, 1 oxygen here, and that's the ozonide. In the next step, ozonolysis takes place, the 2 bonds break and results in the formation of the products. Will have the double bond between the carbon which have the double bonds, the double bond with oxygen. So zinc plus water, and what will the product here be? It will be CH2O. CH2O, and you can put it with a double bond. It can be written with a double bond also. CH2 double bond O plus, what do you have on this side now? Right? C2H5, C2H5, or let me not write this, let me go from this side, following the same pattern that I have been in the previous problems. So I'll write CH3, CH2, this C has the C double bond O and C2H5. Do you see? All I have done is just switched the side, and instead of writing the C2H5 here and the oxygen here, I've written the oxygen here and the C2H5 here to make it easier for me to give the IUPAC name of the compound. This, of course, is methanol. CH2HCHO is methanol. And this here, if I write the C2H5, can also be written as CH2, CH3, because C2H5 means this. It is CH3, CH2. So CH2, CH3, what do I get here now? It is a 1, 2, 3, 4, 5 carbons. So it's pentane 3-one. The pentane 3-one. The one or the double bond with oxygen is on the third carbon. So it is pentane 3-one. Come to the last part now. 4. 4. My pen is getting old. I need a new pen. 1. Oops. I'm sorry. 1 phenyl but 1-ene is the compound. So here I have a phenyl group attached to the first carbon, and the ene, that is the double bond, is also attached to the first carbon, and the parent hydrocarbon is but, which means it has 4 carbons. So let me write down the structure. It has 4 carbons, 1, 2, 3 and 4. The double bond is between the first carbon and the second carbon. It is but 1-ene, and to this there is a phenyl group attached. That is, you could write this. This is the phenyl group. And now let us let us fill it up with hydrogens. This has 3 bonds forming, so 1 hydrogen here, and this has 3 bonds, so 1 hydrogen here, and this has 2 bonds, so 2 hydrogens, 1 bond, so 3 hydrogens. That forms our compound. Now ozonolysis takes place, and formation of ozonide is the first step. As we'll repeat the same thing, these are the 2 carbons with a double bond, so we write everything as it is. So we make the benzene ring, the phenyl group as we call it. The CH is here, the CH is here, CH2, CH3, and the ozone is attached here to form the ozonide. The breaking of these 2 bonds takes place in the presence of zinc and water, or zinc plus water. You have the products. In the products again, everything remains as such. We only write down this bond and this bond are breaking there and resulting in the formation of a double bond here. So you have the benzene ring here, as it is the CH double bond O. Plus the second product here would be, I'll start from this side again, CH3, CH2, CH double bond O. Right? Both of them are aldehydes because the double bond O is on the terminal carbon atoms. This is known as benzaldehyde. And this is propanol. Right? So this is how you would find out the products when you have a compound given and you carry out the ozonolysis. You will first try to, there is a shortcut also. Instead of making the ozonide, when you've just been asked the products and you've been asked to name the products, the formation of the ozonide was not really necessary, unless there are steps in which they expect you to, the question contains more marks where you will get marks for the steps. But if the intention is just to know the products, then you could skip this step. Do not make the ozonide. Straight away break this bond, put a double bond here, O here, and a double bond O here, and whatever the products you get, those are the products of ozonolysis. But the only reason why we go into the intermediate also is for you to understand the process of ozonolysis better. As you repeat it with every problem, it will just solidify in your mind and you will not forget the process of ozonolysis. And you will never get confused in what the products are if you know the mechanism, that is the steps. This is not actually the mechanism, but this is just the 2 steps where you get the intermediate and you get the final product. So in this video, I'll just do this problem. In the next video also, we'll be doing problems on ozonolysis from the NCERT textbook exercise. So if you found this video helpful, please give it a thumbs up. If you want to watch other videos of this chapter, please click the link that is going to appear on your video. And please subscribe to my channel, recommend it to your friends, and please keep returning for more videos on chemistry. Thank you for watching, and bye-bye for now.